about the graph. Thank you.
How's it going, everybody? I'm Brandon Ellis. Our project was the smart irrigation system. You don't see it in here because it is quite large and we would need a forklift to get it in here. So all you get to see is this little beauty right here. This is our wireless receiver for all our data. I'll get to that in a moment. Currently what you're seeing here is the project in total. It's charged by a solar panel during the day. During the night it runs off of a 12-volt battery, and the whole system measures the moisture in the soil based off of resistance. The more water, the lower the resistance, the less the water, the higher the resistance. And therefore it measures based off of that. The whole system used the Atmel AT-Mega 328 PPU, which more commonly is known as the chip they use on the Arduino Uno, if any of you are familiar with that. It's essentially an easy-to-use microcontroller. We chose it because it's got a low price point, reliable performance, and it's easy to program. We're able to get it done within a short time span. And that's the chip right there. This is a sample of the coding. We had over 2,000 lines of code to write this, the whole program altogether. This is the unit installed on the back of the system. We used all watertight enclosures so that in Florida, you never know what's going to happen. We've had rain for about the last 12 days, it seems like, so this thing hasn't been doing much watering, but it stayed watertight so far. That's the internal view of the whole panel. You have the ability to actually switch menus via the controls on board. You can set each individual set point on the system without having to reprogram it at all. You can just dial in your numbers. You can turn off the water if you have rain like we have for the longest time. You can stop it from auto watering, but it won't water if the moisture is already too high in the soil. Or you can just turn it on and just water. You just feel like it. It charges off the solar panel. It's got a built-in solar charger, and it also lets you know how much voltage is coming off the solar panel. These are the moisture sensors that you saw earlier in Jose's presentation. Like you said, they're titanium coated molybdenum and rubidium. They have really high corrosion resistance. I've used copper sensors before and they burn up just like that. So these are the best bets to go with. That is the internal view of the whole system. It's all hand wired, hand built. We didn't use any actual Arduino Uno boards. I soldered the whole thing together myself, and it's all programmed with custom source code. That's the front view of the unit. This is a quick tutorial, just me slowly putting the whole board together. And just take a couple slides of it. That's the finished unit that you actually see inside of here. This is what's running this unit currently. Solder all together. What's nice about this unit is that the outside unit works independently from the internal unit, but the internal unit actually receives all the data that the outside unit is recording and sends it to that little SD card right up there. And that will do it about every 3 minutes. So what we've built up was several days worth of information. We chose the driest days we could so you could actually see a watering event because it's been raining a lot. That's that unit. That's the internal of actualization. We use just standard 413 megahertz transfer chip. It's got a real-time clock in it, which essentially allows the chip to know what time it is, and it can keep track of when each watering event occurred, when it took each moisture reading. Let's put the SD card in. And this is finally the data that we actually receive. So what you're seeing is the photosensor will read at nighttime, and a watering event occurred right here. So you get your moisture going up. The system will only water once the soil is dry enough, and it will only water at night. So you're not getting any evaporation. If it tries to water during the day, it just won't. And if it senses the soil is too moist already, then it won't water either. It'll just skip a day and wait until the soil is actually dry up. So you can see this is actually a bit of rain happening. There's no real way to actually control that. But if you actually look, you can see there's small peaks. These are when the actual watering occurred. The system itself got up to 111 degrees and the system didn't fail, so we know it is robust enough that it can be used on a long-term basis. It's been running out there for about a month and a half. the wireless irrigation system.